In this class, we will discuss about Ritz method. What is this method? Generally, before coming to this method, you should understand principle of minimum potential energy. So, principle of minimum potential energy is what? In structural mechanics, the principle of minimum potential energy is that all the possible displacement configurations a body can assume satisfying the compatibility and the constraint. The configuration satisfying the equilibrium makes the potential energy minimum value. Okay, so in simple language, we can say the total potential energy. Okay, the total potential energy of a particular element or particular structure will be a minimum value. Okay, so any minimum value means what is the differentiation of any minimum value will be a 0. So how we will get the potential energy? So potential energy is nothing but a sum of elastic strain energy stored in the deformation body, okay, plus applied load, applied force, work done by the applied force, okay. So potential energy, which is denoted by pi, which is equals to capital U plus WP. What is a capital U? Is a strain energy, okay, and work done due to the applied load. But the work done due to the applied load will be the negative of work done by the external forces, okay. That's why the strain energy will be uh, what is the and then potential energy will be indicated by strain energy by work, strain energy minus total work done, okay. Is it understand? This is the potential energy. So you are able to calculate the potential energy of any element of given problem. Then how to calculate a strain energy? If there is one stress and one strain, as in case of bar element, the strain energy per unit volume will be, this is a simple concept of strength of material. Okay, the strain energy is a half of strain into stress. Okay, so in the vector form, will indicate like this. So strain energy will be a, this is for the per unit volume. Okay, for the particular complete problem, complete element will be the integration of this. So this is the total strain energy of a particular body or particular element. Okay, so for the bar element, we will see the example of bar element. So in the bar element, in the case of bar element means 1D problem having 2 nodes or 3 nodes. The nodes will be a different, but a single element, one dimensional only. Okay, so it will indicate like this. So as we know, what is the strain? Rate of change of displacement is indicate the strain according to the elastic theory. Okay, so this is del U by del X is a strain, and stress is nothing but a E into stress according to Hooke's law. Okay, stress is directly proportional to the strain. So the small x indicates a direction, x direction. Okay, so if you put these two values in our particular given problem, what we will get? The final output of our problem will be a strain energy is equals to half of A into E. What is A? A is a cross-sectional area. Cross-sectional area of element. Okay. Cross-sectional area of element means the area which is made by width by depth. Okay. And this is the problem for the strain energy. Then work done. What is the work done by the individual distributed load? Distributed load means uniformly distributed load for particular bar element. So we can say as a self-weight also. Self-weight is nothing but a uniformly distributed load. So what is this? How to calculate those? By this equation. Work done by the concentrated load. summation of P into U. Work done is force into displacement. So force corresponding displacement. Force into corresponding displacement. If it is two forces, so P1 into U1 plus P2 into U2. So what is the P1? U1, P1 is the load applied at point and U1 is the displacement of that point. So always U will be the corresponding displacement of the load. Okay. So final potential energy equation will be become like this. So this is the final potential energy equation for the bar element. Okay. As I will show, this is in this problem, for example, we have a two loads. So what will be the equation of this? P1 into U1 plus P2 into U2. So what will be the U1 and U2? U1 is the displacement. For example, this is your, sorry, for example, this is our element. Okay. In this element, one force I applied here. This is P1. Another force I applied here. This is P2. So this is P1. This is P2. Okay. So how will be the work done equation becomes? So U1 will be deformation of this point. For example, this is deformed up to this. So this is the U1. Means this point is deformed up to this length. So this is U1. So this U1 will be corresponding with the P1. Means deformation caused by P1. So, okay. Similarly, this point is deformed up to this. So this is what? U2. Okay. So what is the work done in this case? This is the work done equation for this case. So for calculating the work done equations for particular point load will be simple. Okay. For example, one more load is applied here and in between this. So it will become addition of this two. But what is the deformation constant will be at that point, corresponding displacement with the load. Okay. So this is, I think you understand is what is the work done and how to formulate the equation of work done. Okay. Next is for solving a problem of displacement, you should know some the polynomial. What is a polynomial? How to use this polynomial in the particular problem? I will explain you in next case. So this is a polynomial of the bar element in the trial function will be used like this. So this is the somewhat introduction about the potential energy equation. Okay, minimum potential energy concept. So this discussions is about the Rayleigh's method, how to solve that problem, and your Rayleigh's method is based on the principle of minimum potential energy. Okay, so I think